Good morning, everyone, and welcome back again in our channel. Today we have two examples how to solve exact differential equations. The first one here, and so here is m and here is n. First, we take the partial derivative of m with respect to y and see if it equals to partial of n with respect to x. So here they are equal. Our equation is exact. How to solve this equation? We have partial of phi with respect to x, dx, plus partial of phi with respect to y, dy, equal m dx plus n dx. So first we integrate with respect to x here. And then we find phi of x, y, equal this. And we put, instead of putting in a constant of integration, we put a function of y, because we are integrating with respect to x. So this is the constant of integration, which means g of y. This is equation 1. We differentiate equation 1 with respect to y and equate it to n. So here, then we find g prime of y by integrating both sides with respect to dy, and we here g of y equal minus 2y squared plus c1. Sub g of y in equation 1. Here, this is so phi of x of y equal this equation. And we know our potential function, which is equal c here, equal the new equation. So we move c1 to the other side. So c minus c1 gives us another constant of integration we call c2. Then we divide this equation by 2. So c2 over 2, just another constant, we called it k. So this is our solution. The second choice, we take the partial of phi with respect to y and equate it to m, and then integrate the equation. So our constant of integration will be function h of x, function of x, because we are integrating with respect to y. And it's also called equation 1, the same steps we used in the first choice. Now we will find this function by first differentiate equation 1 with respect to x and equate it to m. Here we are. So h prime of x equal 2e to the power x. We integrate both sides, and here is h of x. Sub h of x in equation 1 here. Again, c1, c minus c1 equals c2. Then we divide by 2. So c2 over 2 will give us this a new constant. And here is the implicit solution. See, we have y squared, we have y. So we leave it as it is. So here, this is the same solution for the two choices we used in solving this example. Here is the other examples. but the variables are t and x, so the same. Then the first we check if the equation is exact. Now we find out they are equal, so it is exact. And means that phi of x is exists such that partial of the same equal this side equal this side. So here m equal partial phi over partial t, n equal partial phi over partial of x. First we integrate partial of phi with respect to t, and integrating with respect to t, and here phi equal this one plus g of x, which is again because we are integrating with respect to t, so our constant of integration will be function of x. Differentiating equation 1 with respect to x and equating to n. Here, equating it to n. We need to find g of x. Okay, and then integrate g prime of x. It will be x to the power 4 plus c1. Sub g of x in equation 1 here, and then phi equal this equation equals c, which is the potential function. And now c minus c1, we called it another constant, c2, same way. And we use the then we divide it by the root square of c2 equal plus minus k, just another constant. And we use the quadratic formula to find x. The second choice, we take partial of phi with respect to x. And again, integrating with respect to x. And this is the our function h of t, because we are integrating with respect to x. So our constant of integration will be function of t. Differentiating equation 1 with respect to t and equating to m. Exactly the same. We find h prime of t, which is integration of 0 will be c1 constant. And so here, and sub in equation 1, and then equal to, this is c, also c2, the c2, then the root square of c2 give us k, plus minus k. Here is our final solution. This is explicit solution, is not implicit, because we just x in one side and all the t's in the other side. So here we see this is the same result, same solution, same x equal the same here and here. Thank you for watching my video, and see you in the next video. In the next video, we will have examples how to use the integrating factor to solve the exact differential equation when partial of m with respect to x doesn't equal partial of n with respect to y. So we use another method called integrating factor method. Thank you for watching my channel. Please, if you see me the first time, subscribe to my channel and give me your like, and thank you very much.